Thank you. All right. Wow, real people. That's awesome. Instead of just webcam figures. How sick are you of raising your hand when somebody asks us a question? Is that getting old yet? All right. Let's talk about React applications. Let's talk about trusted types. So if you're not doing React, you're not supposed to run away, because whatever I'm going to talk about today just as well applies to Angular applications and to Vue applications and Ember and whatever JavaScript application you're building. And even if you're building traditional old HTML or vanilla JavaScript, the same principles are going to apply. The topic is trusted types. React is just one application of this mechanism. All right, let me dive right in. I'm Philippe de Ryck, image source none on error alert. Oh my God. I mean, you're at an OWASP event, you're kind of supposed to know what this means. This means if a malicious user changes their name to something like this and ends up in an HTML page, that's not supposed to trigger the execution of JavaScript code. If something goes wrong, if you have a vulnerability, the application is going to pick this up, render the name, see like, ooh, you want to render an image, try to find it, doesn't find it, and triggers the error message. That's DOM-based cross-site scripting. Well, not necessarily DOM-based, but in React applications, it's going to be DOM-based XSS, or just XSS in general, and that's pretty dangerous. How dangerous? Well, pretty dangerous. That's as bad as it gets in the front end. Just to give you an idea, Facebook pays you 25,000 USD if you find one of these vulnerabilities in Facebook. So that should give you an idea that this is not a minor vulnerability on the sidelines, like, oh yeah, whoops, if this happens, this is a major problem. So this needs to be fixed. And fixing that is not that easy. That's going to be the first part of my presentation, but we'll get to that. We'll get to that. I'm going to talk about trusted types. And the promise I'm going to make you here, I see somebody yawning, so pay attention, because this is what you're going to get out of this presentation. There's no webcam to turn off, so everybody sees what you're doing. The promise here is that trusted types will help us eradicate this vulnerability once and for all. And that's a tall order. If you've been doing web security for a while, you know that cross-site scripting has been there for about 20 years nowadays, I think. And with trusted types, we're finally able to get rid of DOM-based XSS. Not the other ones, but DOM-based XSS, which is the predominant type in modern frontends like React, Angular, Vue, Ember, and so on. And that's what I'm going to talk about today. Before I do that, just a word about myself. I actually look like that picture again because I can wear a shirt and actually have pants on, which is different than when I do things at home. Well, I have pants on, but not fancy pants. And trust me on that. What I do is I do security for developers, basically. I help developers build secure applications through training, either in person, online, or through consulting. And I do that through my company called Pragmatic Web Security. I'm also a Google developer expert and an Azure ambassador. That's like an outreach DevRel program that I'm a part of. I'm not employed by these companies in any way. And I also organize SecOpDev, which is a yearly course. Well, supposed to be yearly. We skipped 2 versions, but it's going to be back in Leuven. It's a week-long course on AppSec, which is something that you really should be at. So we're running that version in June 13th. So look it up and make sure you're there. But back to this guy, this malicious user of our application, this version of Philippe de Ryck. What happens if we put that in an application using React? Here's a very simple piece of React code. Even if you don't know React, you can figure out what this thing is going to do. It's going to render a piece of HTML and insert a name in that HTML, right? There's no problem here. React applies something we call automatic escaping, which means that React is fully aware of what you're doing. It's like, hold on, you're going to put that value in an HTML? That's dangerous, right? So you know what? I'm going to protect you. I am going to make sure that everything that's dangerous in that string will be encoded. So the angle bracket that will start a new HTML tag will be encoded into the %LT semicolon character, which tells the browser render that character, not execute that piece of code. Automatic protection enabled by default. That's as good as it gets, right? And the non-React people shouldn't be disappointed. Every major framework does this. Angular does it, Vue does it, Ember does it. And if you find one that doesn't, my advice is to drop it and find something better, because that one is not going to be very good. All right? This is not the end, by the way. This is just a starting point. Every value you put in your applications this way is going to be protected. That's good. But what about your users who would like to render fancy documents like this stuff. They give you some fancy document like CK editor outputs this, but behind the scenes that's HTML. There's going to be images and paragraphs and headers and all of those things. And if you put that in a page with the curly braces, with data binding, it's going to look like crap because you'll see the actual HTML elements. And that's where in the React world you use a property called dangerously set inner HTML. Set some HTML, you use it like this, you call the property, you provided an object with an underscore HTML property, and there you can provide a review, or, well, a name shouldn't be there, but a document that has some rich formatting. And React will make everything look pretty. Well, React, the browser's HTML parser, basically makes everything look pretty. So what's the process there? You have the data. Your application code is going to handle that data, assign it into the DOM using a sink, a DOM sink like inner HTML. HTML parser picks it up, sees like, ooh, that looks like HTML, I know what to do with that, and you get your beautiful document. That's what I just explained. I'm going to use this picture throughout the presentation to show you how we're going to change things with trusted types, but we'll get to that. What happens if that data turns out to be malicious? What happens if, for some reason, that name of the user ends up there? In our React application, we have that value, the image is there. We assign that to dangerously set inner HTML. React is like, yeah, that's dangerous. Does it anyway. Loads the image. Well, the HTML parser will see that image tag, try to load it, doesn't find it because it doesn't exist, trigger the error, calls the JavaScript engine, and executes that malicious code. That's how a cross-site scripting vulnerability comes to life. DOM-based exists because it happens in the browser. A value is assigned in the browser, triggers the whole problem, and that's our vulnerability. The blue part, by the way, that's React. React doesn't automatically protect you against this. You are supposed to do that yourself. How do you do that? Well, by not using dangerously set inner HTML, that's one solution. But if you really need that rendering of HTML, you need to apply a technique called sanitization. And sanitization is basically taking that snippet of HTML, making sure it's safe first by removing stuff that's potentially unsafe, and then assigning it into the DOM. Here's the vulnerable piece of code. That's what you shouldn't do, hence the red box around it. And here's what you should do. You should use a sanitizer like DOM Purify, which will take that HTML, make it safe, and then you can assign it into the page. Problem solved, right? Brings us back here. We get our beautiful CK editor document, and you did a good job. Awesome. What happens Monday? Your colleague, who isn't here today, he took a snow day, which is exceptional in April, but sure, why not? Your colleague took a snow day, writes some React code on Monday, and doesn't know about the sanitization technique. He's like, oh yeah, I'm going to use dangerously set inner HTML. It's probably fine. It's not that dangerous. And he has a vulnerability. It basically writes something to a dangerous sink, basically results in the execution of JavaScript code. And if you're like, yeah, but my colleagues are smart, they don't do that. Well, maybe not that colleague, but somebody else will. Now, in the future, doesn't matter. There's plenty of cases where this happens in practice, plenty of cases where a developer misses something, even in very security-aware applications like Signal Messenger, claiming to be one of the more secure messaging applications. Their desktop version, written in React, had this exact vulnerability. Somebody misused dangerously set inner HTML, and boom, you had a cross-site scripting problem. By the way, there's other ways in React to mess things up, just to make the picture a bit more complete. You can also grab a native DOM element with a reference, and then access inner HTML directly. Don't even have to call it dangerous in that case. You can just sidestep the danger and do dangerous things as you would have done in normal JavaScript, which is not the best way of doing things. And the third way to mess things up, well, there's more, but I'll have to draw the line somewhere. The third way to mess things up is to use hrefs. If you have an anchor tag where you insert a JavaScript URL, that's potentially dangerous, right? If the value that ends up here is a URL starting with JavaScript something something, the browser, when the user clicks it, the browser will execute that JavaScript. A very weird pattern, a very dangerous pattern that probably should die, but doesn't, because a lot of applications actually use that for legitimate features. React is catching on that this is not the bestest of ideas, because they're showing you a warning when you do it. Like, yeah, that's dangerous. You shouldn't do that, developer. I'm warning you, it's marked as an error, but it's not an error, it's a warning, just like a very serious warning, and React is going to do it anyway. And this warning doesn't stop the behavior, React detects it. It's been there since, I actually went into GitHub to check for it, March 12th, 2019, and it's still there today. There's a new React version, 18, since about 3 days, I think, and it's still there. Still the warning, no protection done by default. So the first takeaway. Avoiding cross-site scripting in React applications is challenging. There's a whole bunch of pitfalls, a whole bunch of getting things wrong that result in cross-site scripting vulnerabilities. And real-world React apps show that. Whenever I run a workshop, people learn about all of these pitfalls. They go at their code base and they come back like 2 hours later after I covered it, like, oh yeah, crap, we found 2 vulnerabilities in our production applications. Thanks for that. That's the real world. And the same for other frameworks, by the way. Even in Angular apps, people find vulnerabilities. Angular is better security-wise, but people still find vulnerabilities in their code. So this is a serious problem that can't really be solved. Trusted types is going to help us here. And that's going to be the second part of my presentation. Trusted types comes from Google. It's a Google-based, it's a technology invented by Google, used internally for a long time, and then eventually standardized into a browser-based security mechanism. And Google started working on that because their static analysis tools failed to find these DOM-based XSS vulnerabilities. They did a lot of static analysis. They have the best tools you can imagine, built by the best people money can buy, basically. And their tools still failed to find a whole bunch of DOM-based XSS vulnerabilities. So they said, like, okay, we need something else. Static analysis doesn't work very well for this problem, so what else can we do? And that brings us to trusted types. All right. What do we do with trusted types? We enable that. To enable trusted types, you set a security header called Content Security Policy. That's this very elaborate security policy with like 1,001 features. One of these features nowadays is require trusted types for script. So you can basically enable trusted types for script-based content. And what that does in the browser, when the browser observes that header, the browser will be like, oh, okay, I'm going to transform that dangerous sink, that inner HTML, into a trusted type sink. And what that means is, it basically means that whatever you assign to that specific sink, inner HTML, outer HTML, document.write, document.write.ln, has to be a trusted type. If you try to assign that text-based value, like Philippe direct something, the browser is like, yeah, no. That's not what I do. I'm not going to do that. It simply throws an error, and the problem kind of goes away. Your vulnerability is no longer there because the code or the data is never assigned to the DOM, and the browser will never pick up the malicious code. That's what trusted types does. It removes text-based assignments to inner HTML and its cousins or siblings, and forces you to use trusted types instead. Awesome, right? It changes the behavior of the browser. Before we talk about the details, it doesn't affect anything that's not HTML parsing. If you want to use DOM APIs, like create element, set attribute, append child, all of those things, that's legitimate API code. Using DOM APIs, that's perfectly allowed, even with trusted types enabled. It doesn't impact that at all. That's a programmatic way of building elements and a DOM tree, that's fine. It does affect HTML parsing. If you assign something to inner HTML, that's when trusted types really kicks in, and that's the protection it offers. So basically, when you're trying to assign data, text-based data into a page, that's where trusted types is really affected. Stuff like this. So how do you get your CK editor document? You can't really process this into JavaScript APIs like create element, paragraph with this text. It doesn't work like that. You get this as a string, an HTML string, and you want to assign that into the page again as an HTML string. That's the whole idea of this way of rendering that data. So how do we do that with trusted types enabled? If we try to assign it, it's going to throw a big red warning, a big red error in this case, and break. So you have to provide a trusted type. And the easiest way to get the trusted type is by using DOM Purify. That sanitizer from before, you can tell DOM Purify, if you're done sanitizing that value, just return a trusted type instead of a string. And DOM Purify is like, sure, I'll do that. And it will sanitize the value, give you a trusted type, you assign that trusted type into the browser will check that and be like, oh, trusted type, cool, bam. And it renders that document in the browser. That's what trusted types really enables. Sorry about that. That's pretty awesome. Back to that image. So now you apply sanitization the right way, you mark it as a trusted type, you assign it in the DOM, and everything works as expected. You get your CK editor document, you're happy, your boss is happy, your customer is happy, happy life. And then on Monday, that colleague, it's like, yeah, whatever. Dangerously set inner HTML with the value, bam. And they do that anyway, and the browser sees that, and the browser says like, hey, I'm running trusted types. Like, no, dude, I'm not going to do that. And the browser simply refuses. So your legitimate feature works. You sanitize, mark it as trusted, assign it in the DOM. It works. Legitimate code has no problem. A vulnerability, a mistake somewhere in the application will result in an error. It will basically not result in the execution of malicious code. That's what trusted types can do for us. Trusted types doesn't do anything, basically. It's a trusted types, it's basically a kind of a type-checking mechanism. It changes a tiny thing in the API, preventing traditional legacy uses of that specific sync. So all the legacy uses of assigning text to inner HTML because it's the easiest way, like, yeah, whatever, no, out. Legitimate behavior, things you have changed, like, oh yeah, let's make this trusted, that's something that can actually work, and that's what trusted types really enables. It allows you, or it forces you to provide specific trusted types. That's what it does. And it modifies the browser behavior to achieve that. Awesome. Are you excited about trusted types? Like, yeah, this is good. Everyone's like, oh, I want to start using that. So which browsers support that? Like, it's a Google thing, so Chrome. And Chromium-based browsers. So yeah, when you see a graph like this, you probably know, can I use? And when there's like that much red, it's probably not a very positive story. Well, in this case, it doesn't really matter. And that's part of the coolness of trusted types. Who here is using Chrome for their development purposes, by the way? Let's show some hands. 2 people, wow. Who's using Internet Explorer for development purposes? Okay, so most people are using Chrome. But okay, let's assume that all of you use Firefox. Why not? All of you use Firefox, and our friend here uses Chrome. Good. Let's make you the developer. Let's make you the users of the application. You're going to develop in Chrome. And you're going to enable trusted types in development mode. And you're going to build your application, and you enable that, and you're going to get like if you're using React at least, like a shitload of errors. Sorry for the language. Like a ton of errors. And you're going to be like, oh yeah, let's enable trusted types, and let's do some sanitization the right way, and let's fix that. So all of this dangerous code goes away. These are vulnerabilities, and you fix that by using DOM Purify and returning trusted types. Good job. It's going to take you a bit of effort, but it's something necessary, something we need to do. Awesome. And if you've done that, you're very happy, and you have a secure application in Chrome. And then all our friends here using Firefox visit your application, and Firefox is like, yeah, I don't know what that means. Trusted types, what? I'm not going to do that. But it doesn't matter, because the application code now looks like this. Because you enable trusted types, you were forced to look at every insecure assignment into the DOM, or potentially insecure assignment, and you were kind of forced to go and fix that to make the application work for you. Which automatically means that your application now contains secure code, with DOM Purify sanitization, which is the recommended defense against cross-site scripting, and it kind of solves the whole problem. And that's awesome. You can enable trusted types in development only to force you to build a more secure application, and your users in production, who won't even know what trusted types is, benefit from that. And that's beautiful. So all you Internet Explorer users, you can be rest assured, because he uses Chrome, you will be more protected. And that's awesome. Sorry for attacking you for using Internet Explorer, by the way. And if you really want to, you can include polyfills as well. So there are JavaScript polyfills you can include to enable trusted type support on non-supporting browsers if you want to. But it's not necessarily required at this stage. So trusted types improves code security. That's the benefit here. It's not necessarily a runtime protection, as in you have to always have it enabled. It's more like a way to remind you, like, hey, you're assigning a text-based value here. Are you sure you want to do that? Maybe you need to sanitize that or make it safe in another way. As long as you thought about it and applied proper defenses, we're good. That's what trusted types does. All right. Good. So now your entire application is secure. You're building a secure app. You're assigning everything through DOM Purify or another mechanism. Make it safe before you put it in the DOM, and there's no vulnerabilities. Well, that's probably a lie, but let's assume there are no more vulnerabilities. Good job. However, only a tiny part of your application is yours. You probably have a bunch of third-party code dependencies. Wait, that doesn't look very right. It's probably more like this. A lot of third-party code dependencies and a little bit of code from your end. Seriously, if you bootstrap a new Angular or React app, you probably get a few million lines of code from dependencies without writing a single line of code yourself. That's the reality of building applications today. And what happens if one of these third-party dependencies assigns something into the DOM in an insecure way? Cross-site scripting. Very simple example from the past, Bootstrap. I mean, one of the most commonly used styling frameworks. They had a feature to enable tooltips with some HTML in the tooltip, so you get a fancy tooltip, and an attacker could abuse that feature to insert malicious code in your application. Because Bootstrap is not your code, they didn't sanitize that value, they just inserted it with inner HTML, causing potential cross-site scripting problems. Well, remember where trusted types really applies. Trusted types applies below the line. It's a browser-level defense. It changes the browser platform. It's not application code. It changes how the browser behaves, and it basically throws an error. It says to Bootstrap, like, what the hell are you doing? Why are you assigning text into a dangerous sync? Like, we don't do that here. And it refuses to create a tooltip, which is a good thing, because it protects you, but it also probably doesn't make you very happy if you want that tooltip. That brings me to the last piece of the puzzle here. And the last piece of the puzzle is a default policy. You can write a default trusted types policy. Well, you can write non-default policies as well, which is something I kind of skipped. But you can write a default policy, which is aptly named default, that the browser will automatically apply whenever it finds an unsafe assignment into a dangerous sync. So basically, you're supposed to write proper code yourself, like sanitize the values wherever they need sanitization. But if you're trying to apply this application-wide, even for code you haven't written, you can use this default policy mechanism. So what you basically do in this case, let's walk over it. You define, that doesn't work as expected, so I'll have to check my live setup. Whatever, on line 5, you basically call the trusted types API, and you create a policy. That's essentially how you enable trusted types manually without using something like DOM Purify. You give the policy a name, default in this case, and in that policy you can specify how to transform an unsafe piece of HTML into something safe using the create HTML function. That's what the browser will automatically call when it's looking up this default policy. You take a string as input and you give something as output. In this case, we use DOM Purify. So what we do now is we tell the browser, every time you find a text-based assignment to inner HTML, stop it, run it through the default policy, sanitize it, and what you get out of that is a trusted type. That's what you can assign into the page. And your Bootstrap library trying to pull one over on you by creating a potential XSS vulnerability will now be forced. Well, it doesn't change, but the browser will stop it, pick it up, make it safe, and assign it into the page. That's essentially how trusted types works in practice. And that default policy allows you to apply this application-wide, even to code you haven't written. To code that has been there since 1999 and you don't want to touch to update with trusted types. Like, yeah, we're not touching that. Well, maybe a default policy could be of some help to make even that application more secure. Fair word of warning here, if you are using this, you transform trusted types not as a detection mechanism, but you transform it into a runtime protection mechanism. You need the polyfills. You need all the polyfills to enable this in non-supporting browsers, otherwise things will break. So if you try to enable a default policy in Firefox, it's not going to work because Firefox has no idea what it means. So you need to load those JavaScript polyfills to enable that behavior in JavaScript. And that fulfills the promise I made in the beginning. So trusted types is a browser-level measure. It changes the way the browser accepts data, which does two things. It forces you to change the way you provide data, which forces you to think about security and apply proper defenses. That's one. And the second thing is, with a default policy, you can build like a catch-all that automatically captures text-based assignments and transforms them into something more safe before it's assigned to the DOM. And that transformation step you apply there, that's your security process. That's where you apply things like sanitization or whatever else you think is a good security measure there. But it's going to be sanitization if you want to get this right. All right. If you want to know more, here's a link, web.dev/trustedtypes. That's from the author of Trusted Types, Christoph Kadowitz, Google engineer, really smart guy. And he explains a couple of examples of how to use trusted types, also explains how you can write your own policies if you would want that, which is not something you're kind of supposed to do, but sometimes you might need that. So you can go there for additional information if you want to. I also have some security content myself, courses and so on. You can check that out if you're interested in that. And with that, I want to thank you for being here. Thank you for listening. If you have any questions about this mechanism, I'd be happy to answer them right now. So let's make Seba run around a bit.
All right. Yes.
Thank you.
Any questions? Yes.
All right, thank you. So the default method you just showed actually is, enforces the DOM purify. But does DOM purify sufficiently clean all input for all contexts in which it can be placed, or might there be a bypass in that some way?
DOM purify should cover all of these scenarios, yes. So let me skip back to that slide so we actually can see what we're talking about. So we're creating HTML. So we're going to assign something in an HTML-based context, and DOM purify is a sanitizer with a sane set of defaults that will make sure that whatever you get out of there is safe to put in that context. If you find a bypass, that's always possible. It has happened in the past. DOM purify is covered by bug bounty programs, so go there first and get your money, and they will fix it and update it. But yes, it's a safe library. It's built by Myro Heidrich and co, who are the experts on cross-site scripting, so they definitely know how to cover that. So yeah, I put my faith on DOM purify in this case.
So just to double check my understanding, is this header only supported right now by Chrome, or it's work in progress for Firefox and other? Is it like, for example, part of one official RFC? What is the status?
Yeah, so there's two things, basically. You have the header to enable trusted types, and you have the policy mechanism to create policies like the default policy and so on. And both kind of belong together. So trusted types is not part of, I honestly don't know if it's part of the CSP spec. Maybe it's mentioned somewhere, but the browser typically supports both together. And that's only the Chromium-based browser. So Chrome and Brave and Opera is also based on the Chrome engine and so on. So yeah, that's only supported by those browsers at this moment. Firefox will just ignore it. It will not throw errors. And if you write trusted types code, there's going to be like a feature check if trusted types exists and create a policy. Otherwise, just ignore it. And unless you use the default policy, there shouldn't be any hiccups. So, for example, DOM purify, if you use it and you tell it to return a trusted type in a non-supporting browser, it's not going to throw up errors and be like, I don't know what to do. It's just going to be like, oh yeah, sure, I'll just return text as normal. So it keeps working in Firefox even when you, let me skip back to that code example. When you write code like, yeah, here we have it. Code like the one at the bottom, return trusted type true. In a non-supporting browser, DOM purify will just return text, like it would always have done, and your application works as normal, but without the trusted types protection. Sure.
So, is there a time where you would not recommend having this header? For example, in a specific context of a JavaScript application or front end, we might have maybe, I would say, interoperability issues with other, I don't know, like library or browser engine.
There's two aspects to consider. In development mode or development, I would say there's not really a use case to not use trusted types unless, well, it may be difficult to do so. So if you're not using DOM Purify, but you're using a different sanitizer and it doesn't support trusted types, you'll have to write a policy that basically takes whatever that sanitizer does and makes it a trusted type. So it's a bit more effort, but in development, it shouldn't matter. Deploying this in production, I would be a bit careful with that if you are not 100% sure that the application you've written has covered every case. Because if there's one you haven't covered, then you end up in the scenario we covered here. If there's something you forgot to cover, then that piece of the application is going to break because it's the red arrow sidestepping that sanitization. But if you're 100% sure that you've covered all the assignments to unsafe things, like inner HTML and outer HTML, then there's no reason not to use trusted types, basically. But my advice would be enable this in development, especially for new projects, because it's going to force you to write better and cleaner code, and also try to enable this for existing projects, just for the hygiene aspect. The moment you do something wrong, trusted types will tell you, like, are you sure you want to do that? And then it's up to you to think about whether you want that or not.
Okay. All right. Thank you very much, Philippe.
You're very welcome.